Assalamu alaikum, our respected teachers and fellow classmates. I am Sheikh Shahir Hussain, ID 111, starting our project presentation for the course Tripoli 304 Digital Electronics Laboratory. We are Group 2. My other group members are ID 103, 104, 115 and 125. Our allotted project was Traffic Control System Modeling and Circuit Prototyping for Raju Memorial Sculpture Roundabout and adjacent roads of TSC. Here we need total 5 signals to control the traffic smoothly. Among these, 4 signals are controlling traffic flow entering the roundabout and 1 signal controlling Samsun Nahar Hall road traffic. Now let's move on to the work done and the concept. Starting with 555 timer. The 555 timer works in a stable mode where its output pulsates from high to low. The period of the pulse wave and the duty cycle depends on resistor R1, R2 and the capacitor C. In our case, the value of the resistors were 10 kilo ohm and the value of the capacitor was 47 microfarad. So the on time was 0.651 second and the off time was 0.326 seconds. So the total time period was 0.977 seconds. So our frequency was 1.023 Hz. Pins responsible for making the output go high and low are the pins trigger, pin 2 and the threshold pin 6. The trigger pin is responsible for setting the output high. When the voltage on the trigger pin goes lower than 1/3 of VCC, comparator 1 output becomes high and sets the flip-flop high, which in turn sets the output pin high. Pin 6 is labeled threshold. When its voltage exceeds 2/3 of the VCC, it is responsible for resetting the output back to low. Here, trigger and threshold pins are shorted, so they respond to the capacitor charging and discharging and get self-triggered.
Assalamu alaikum. I'm Mr. Shakil, ID 1706125. I will discuss about the Johnson decade counter IC4017. It is a synchronous counter. It has 10 output pins named Q0 to Q9 and a carry out. It takes clock pulse as input. With each clock pulse, its 1 hot encoded output shift to the next one and bounce back to start as it reaches the in Q9. The carry out pin stays high for Q0 to Q4 pins and goes low for Q5 to Q9 pins. It takes about the period of the input clock pulse to shift to the next consecutive input. It takes a total time of clock period times 10 times to finish one cycle. We provide our 555 stable multivibrators output here as input clock pulse. We determined to provide approximately 5-second duration for both green light and red light in each traffic signal of our prototype. The carry-out pin provides an easy solution for that. As our 555 timer produces clock pulses at 1 second difference in between, the carry-out stays high for 5 seconds and low for another 5 seconds. We designed the rest of the signal light control circuit relying heavily on this concept.
LEDs. I am Nafisa Noor, ID 1706104. So here we have connected an arrangement of AND, OR and NOR signals to dictate red, yellow and green signals timings and not to overlap lights, and to prevent multiple lights staying on at the same time. We design in such a way that red or green light doesn't stay on when yellow light is on and vice versa. The pedestrian lights red and white is turned on or off at the signal end. To supply power to our logic circuit and LEDs, we have used a computer's USB port. Modern USB ports have the capability of sourcing 5 volt and 500 milliampere max, so it is adequate for our project with enough headroom. And USB-A cable was stripped to find the red and black marked wires that sources 5 volt and ground respectively. An SPDT switch with 250 volt handling capability was used for the ease of turning on and off power. The 3 MOSFETs are P MOSFETs, model name IRF9530. From their output characteristics found in the datasheet, we can be sure of that the sources of all them are connected to 5 volt and gate is connected with the 4017. And conditional assembly. Drain is connected to supply power to green, red, yellow LEDs all over our model. Cheaply available LEDs that emit red, yellow and green and white were used to represent the signal lights. The 5 volt might damage the LED lights as the LED is connected to in a forward bias condition across a power supply. It should be current limiting using series resistor to protect it from the excessive current flow. LEDs shouldn't be connected directly to a battery or power supply, as it will be destroyed almost instantly because too much current will pass through and burn it out. Most common LEDs require a forward operating voltage between approximately 1.2 to 3.6 volt with a forward current rating of 10 to 30 milliampere, with 12 to 20 milliampere being the most common range. Our LEDs vary vastly on how much voltage is needed for it to perform spot on with maximum brightness. It was decided to use 220 ohm resistors in our testing. With available resistors, it gave good brightness through LEDs of all colors.
Hello, I'm Fahim Abid, ID 1706115. We have implemented manual control as well as automatic timing based control in parallel to manually switch on and off either for red or green. Two push buttons were required for each signals. These are DPDT switches. Their poles connect to a network of MOSFETs that control the switching operation. When the push buttons aren't pushed in, that's in their normal state, they are connected straight to the power supply MOSFETs. But when red LEDs push button is pressed in and latched, it turns off both yellow and green at the signal and supplies straight 5 volt to that LED from the power rail, thus making sure only red can stay on. Same was done for green LEDs push button too. Each signal needs a 4 P channel IRF 9530N MOSFET assembly to control the switching.
Hello, my name is Shayanto, ID 1706103. The components used here are 74193 BCD decade counter, up or down, and 7447 7-segment common anode decoder. As previously mentioned, we have designed such that our 555 timer outputs pulses at 1 second interval, so we can easily accurately display remaining time in seconds with a down counter. We are using 74LS193 IC. It can count both up and down, so we have set it up so it only counts down as so acts as a timer. The up pin is set on high and down pin is fed from the 555 timer's output. As previously mentioned, our prototype signals red light for 5 seconds, so after 5 seconds the timer should reset itself. We designed some logic circuitry to detect when 5 seconds passes and to reset our timer. The timer loads number 5 when not used to prepare for the next counting. The pull up pin is used to reset or load the number 5. We also made sure to check when green is on in that signal, so the timer only keeps time for red light. The BCD counter outputs its current state with BCD code on pins marked Q0 to Q3. Now, to display it in human readable form, we have used a 7-segment display, common anode variant. In common anode display, a segment lights up when 0 volt is applied to it, and it has a common 5 volt pin for all the 7-segment LEDs. Decoder 74LS47 is used to drive the display. It simply takes input from BCD counter's 4 pins Q0 to Q3 and lights up the required segments to represent a decimal digit in human readable form. Thank you.